In this Click and Learn series or lesson, we'll explore the attributes of circle theorems so that we'll get a better understanding of circle theorems. Now, many students find it difficult understanding circle theorems, and so as a consequence, they find it very challenging solving problems related to circle theorems. In fact, many students avoid questions related to circle theorems because of the difficulty they have with the fundamental concepts and principles and theorems related to circle theorems. So in this lesson, we learn about circle theorems through observation and exploration. We'll observe closely what happens when we play around with the figures and when we make changes to the sizes of angles, etc., and we make certain inferences. We form a conjecture and see whether that is true or not. So let's begin. On your screen you see a circle, and inside that circle you see a figure. You have a chord AB from one point on the circumference, another point on the circumference, then another chord from B to C. The point is on the circumference. You see the center of the circle D, and there's an angle formed there. There's a DC is a radius, and DA is a radius of this circle. Now we want to know what is the relationship between the angle at the center of the circle here and the angle at the circumference of the circle. Now it will help us if we saw the measurements of these two angles. So let's see the measurements of these two angles. And it shows you that angle CDA, this angle here, is 57 degrees, and angle CDA is 114 degrees. Now observe closely the relationship between this angle and this angle. What do you observe about the sizes of these two angles? Well, the first thing you can observe is that one angle is bigger than the other. This angle here is bigger than this angle here. This is 114 degrees and this is 57 degrees. What other attributes can you perceive in the relationship between this angle and this angle here? Well, you can observe that this angle here is twice this angle here. Now, is it always the case that the angle here at the center of the circle is twice the angle at the circumference? Let's see. In order to see that, we need to play around with the diagram. Now, let's move this radius here, DA, and see what happens. We move it, and the angle here has become 102 degrees. And the angle here is now 51 degrees. What is the relationship between the angle here, it's 102 degrees, and the angle here? It appears to be twice the angle at the circumference. Let's move the position of this arm of this chord, and let's move this chord here and see what's going to happen. Here again we see the angle here has changed, become bigger, 116 degrees, and this angle has become 58 degrees. What relationship then exists between the angle at the center and the angle at B? And we see it is twice the angle at the circumference. So what conjecture, what theory can you come up with? Well, one is that the angle at the center of the circumference, formed by the chord CA, is twice the angle at the circumference. The angle at the center is twice the angle at the circumference. And so from observation and from measurement, we have the theory that the angle at the center is twice the angle at the circumference. We have theorem 1.